Happy day students, welcome to class 10 physics, chapter 13 magnetic effects of electric current part 3. Now we have electromagnetic induction, which is explained by Michael Faraday. The motion of a magnet with respect to a coil or a change in the magnetic field induces a potential difference in the coil and produces induced current. This is called electromagnetic induction. It means motion of a magnet with respect to a coil produces induced current. If a magnet is moved towards or away from a coil of wire connected to a galvanometer, the galvanometer needle shows a deflection. This shows that current is induced in the coil due to the motion of the magnet. You can see the image. We have a circular coil like a solenoid and we are inserting a magnet into it, so it acts as an electromagnetic induction. It means induced inside the coil. Change in magnetic field produce induced current. Take two coils of wires wound around a cylindrical paper roll. Connect one coil to a battery and the other coil to a galvanometer. If current is passed through the first coil, the galvanometer needle shows a deflection in the second coil. If the current is disconnected, the needle moves in the opposite direction. This shows that current is induced due to the change in the magnetic field. Galvanometer is a device. It's an instrument that can detect the presence of a current in a circuit. The pointer remains at 0, that means the center of the scale. For zero current flowing through it, it can deflect either to the left or right, the right of the 0, marked depending on the direction. The direction of induced current is given by Fleming's right hand rule. It states that if the thumb, forefinger and middle finger of the right hand is held perpendicular to each other such that the thumb points in the direction of motion of the conductor, the forefinger points in the direction of the magnetic field. Then the middle finger shows the direction of induced current. You can see the thumb acts as a force and the forefinger which acts as a magnetic field and the middle finger which acts as a induced current. Direct and alternating current DC and current that always flows in one direction only is called direct current. The current we get from a battery is a direct current. Alternating current AC. A current that reverses its direction periodically is called alternating current. Most power stations in our country produces alternating current. AC changes direction every 1/100 seconds and its frequency is 550 Hz. One advantage of AC over DC is that it can be transmitted over long distances without much loss of energy. You can see this, there is a straight directed and we have a alternating current in the graph representation. What is electric generator? An electric generator is a device in which mechanical energy is used to rotate a conductor in an area of magnetic field to generate electricity. Electric generator is based on the phenomenon of electromagnetic induction. It is based on the principle of Fleming's left hand rule. Parts of generator are permanent magnets, galvanometer, rotating rectangular coil, rings, brushes, axle. Working of electric generator. When the axle attached to the rings is rotated such that one arm moves up and other moves down in the magnetic field produced by a permanent magnet. By applying Fleming's right hand rule, the induced currents are set up in these arms along their direction. Thus an induced current flows through the direction of ABCD. After a off rotation, arm CD starts moving up and AB moving down. As a result, the direction of induced current in both arms changing, giving rise to net induced current. Domestic electric circuit. Electric power to homes is supplied through the mains. It has two wires. One is a live wire, that is positive wire with red insulation, and the other is a neutral wire, that is negative wire with black insulation. The potential difference between the two wires is 220 volt. The earth wire with green insulation is connected to a metal plate kept in the ground. Two separate circuits are used. One is of 15 ampere for appliances with high power rating like gases, air conditioners, etc. The other is 0.5 ampere for fans, bulbs, etc. The different appliances are connected in parallel so that every appliance gets equal voltage, and even if one is switched off, the others are not affected. The appliances having metallic body like electric iron, refrigerators, etc. Their metallic body is connected to the earth wire so that if the leakage of current, it passes through the earth and prevents electric shock. Electric fuse. Electric fuse is a safety device used in electric circuits to protect the circuit and appliances from damage due to overloading and short circuit. It is a wire having high resistance and low melting point. If excess current flows through the circuit, the fuse wire melts and breaks the circuit. Fuse wire is made of a metal or an alloy of metals like lead, tin, aluminum, and copper. Fuse wire is connected in series with the live wire. Overloading. Overloading is caused due to increase in voltage or if the live wire and neutral wire comes in contact or if too many appliances are connected to a single socket. It results in overheating of the wires and can cause damage to the circuit and appliances. Short circuit. Short circuit is caused when the live wire and neutral wire comes in contact and the current suddenly increases in the circuit. It causes spark, wire and damage to the circuit and appliances. Thank you, children.